So I'll just give you a bit of overview on my thoughts on integrating gene drive technology into NMCP toolkits. I was asked to see, some strategic considerations, its potential, based on the work that I'm doing, since it's in this line. And so I'll just give you an overview that there are various groups that are looking at developing, gene drive solutions for malaria vector control. And the most advanced along the development pathway in that would be probably those three. And they're looking at different strategies that will harness gene drive. Some are looking at suppressing the densities, so that's population suppression. So they modify a gene drive to effect that. And then others are looking at making the mosquito less able to transmit the parasites. So that's an alteration or population replacement. So the mosquitoes remain, but they're just not able to transmit. And they are pursuing a phased approach. So everything doesn't happen at once, but essentially start with proof of concept, discovery, studies in the lab, which involve construct design, genetic transformation, that part, and then move to the next phase, which will be, contained use lab work, where they're looking at whether it really works. So evaluating it in a contained environment, and then ultimately what we really want to see is evaluation out in nature, of course in some confined field release for efficacy. So I'll say where things stand now. There's no gene drive-based tool that's ready for vector control deployment. We are still in the R&D phase, so a little bit further back. But still we can talk about what we think it will take to make, the NMCP probably, adopt those. And so the development strategy has been collaborative and phased, like I've talked about. So the gene drive itself, the reason we're looking at it is that there's a problem, and that's to do with the tools that we're having and them reaching their limits in terms of controlling malaria, leaving various protection gaps, in their wake. So now gene drive, of course, offers opportunity or ways that will be novel in controlling the malaria transmitting vectors. And so inbuilt into it are aspects where they can be more sustainable, the tool can be more long-term, the tool can be more cost-effective. And all those that I've shown there are some of the intended features for a gene drive approach in that effort. Now for the NMCP to uptake it, my thoughts are a number of things need to fall in place. So obviously the most important, I think, would be evidence that it really works. So some evidence generated from the field that the tools that we're talking about have, or this data that vouches for their strong entomological and epidemiological impact. Yeah, if they don't show that, then there should be no reason why NMCP should be interested in them. But there are also other considerations. For example, the compatibility with existing interventions. They shouldn't be made to overhaul everything just to accommodate this. So if it's there, that will be very desired. And then the scaling up, feasibility, that's also important because they'll be working at the countrywide level. So NMCP need to see something that's scalable and that's possible. And then if there's some recommendation by others, not only just the researchers or developers, that will go a long way. Maybe WHO, VCAG endorsement will help. And then of course, how cost effective is it? So you need to see the figures, and the numbers and be reassured that it's really cost effective more than what they have. Of course, there are other stakeholders that also have some input that's also important. For example, some of the regulatory bodies, like the NEMA, the evidence that we'll bring will come from some field releases that will be in form of some application. So they need to see that at least that's possible to do the confined field release in the framework that's there. And it will be interesting to see whether NEMA thinks that's enough or more needs to be added. And then there's also environmental risk assessment. They'll scrutinize the mitigation measures that have been proposed for unintended consequences. Those have to be cleared. And then when it comes to the issue, environmental social impact assessment, there's scanty field data on the role of mosquitoes in the ecosystem. I think that has to be strengthened and changed because it'll be very important in the evaluation. And then how to monitor after post-release, and then balancing technology risk and the benefits, transboundary issues. So all those things have to be navigated before we get there. Then, of course, Minister of Science and Technology and Innovation, at least case for Uganda, For them to be very excited about this and embrace it, they need to see, or at least they give advice on intellectual property arrangements that are in place, whether they have flexibility on repurposing this technology to control other vectors as well, profit benefit sharing arrangements, economic impact. They may need to see some projection on numbers there. And then, of course, scientifically, they may want to know what happens if, let's say, suppression is successful, what species will come next. And then they want to see homegrown biotech capacity. Of course, there are other issues to think about when it comes to evaluation. How do you design a trial of that magnitude that uses gene drive? There are conventional trial designs that are out there, but they all don't fit quite very well. Some of them may need to be tweaked because of the endpoints that we're looking for. So maybe an adaptive trial design could be the way to go. We'll check with lots of experts and see whether that's the case. Basically, one thing, it has to first clear the genetic efficacy, where we ask whether the transgene can be introduced into the natural population and make it spread. So if it clears that, then we start looking at entomological efficacy. Does it have an impact on the mosquito densities? And then if that's the case, then we can start asking whether there's epidemiological impact in terms of, impact on the malaria, etc. But maybe you can't look at all that in just one trial. So those thoughts need to be, addressed. And then there are the logistic things, even during the trial stages or even post, later during deployment, where you place the facilities for production. Sometimes you may need to change on how you feed your mosquitoes. You may think about artificial blood mills, what stage is ideal for transportation. A lot of automotion will be needed when it comes to producing the numbers, and then how to monitor, how to do surveillance, and a lot of challenges in the life history traits themselves also come into play. Then obviously the stakeholder engagement is also important, because we are not only just developing this for ourselves, it has to be used. We hope that the community can embrace it and of course buy into it. So the stakeholder engagement has to be done early so that they're on board from the outset. And obviously projects need to do this, and at Target, that's what we do. And then during the engagement, we've seen questions that are not very different from the ones that we've seen this week from the regulatory, training that we had. People ask more or less the same questions and need to get answers on those if they are to be convinced that this technology will not be harmful to them. So in a nutshell, I think for adoption, we need that there's a record or evidence that it works, so efficacy, and then there's capacity around to do the evaluations, of course, and then the infrastructure is there and in place, and then the technical expertise is also there, and then regulatory systems for oversight and product development are also there, and they can be trusted, and then the public support, political will for technology uptake needs to be sought for, and then when we think about now, not the research, but just deployment or commercialization, then at least case for Uganda, we may need a lot to make sure, it's backed up by that. So those are just my thoughts on what it would take to have adoption of this emerging technology. Thank you.